Let's look a little more closely now at different types of organic compounds, starting with hydrocarbons. Hydrocarbons are compounds made up of carbon and hydrogen atoms, and they fall into two major categories, aliphatic and aromatic. Aliphatic hydrocarbons, those carbon compounds with carbon atoms connected in a straight chain, can further be separated into three classes of compounds: alkanes, alkenes, and alkynes. Aromatic hydrocarbons are carbon-containing compounds connected to form cyclical or ring-like structures and generally have some sort of smell or odor to them. Let's look more closely at the aliphatic hydrocarbon known as alkanes. These hydrocarbon chains are made up of all single carbon bonds. They're also known, as we saw previously, as saturated hydrocarbons because they are saturated with hydrogens. Alkanes have names that use the ending ane. Examples are methane, propane, butane, which you can see the structural formula for, and then others, octane and others. The general formula for an alkane is CnH2n plus 2. So we have twice as many plus 2 hydrogen atoms as we have carbon atoms, if N is the number of carbon atoms. The name and formula for the first 10 alkanes is shown, and so let's just pick one, heptane. Hept meaning 7, so we have 7 carbon atoms, C7, and then the hydrogen atoms are twice as many, 14, plus 2, so we have 16 hydrogen atoms. Here we can just see the formation of those structural formulas for the first 3 alkanes. So if I have 1 carbon, I can saturate it with 4 hydrogens, so CH4 is methane. If I have 2 carbons single bonded, that leaves room for 6 hydrogens to saturate it, giving C2H6 or ethane. And if I have 3 carbons in a chain, that leaves room for 8 hydrogen atoms for it to be saturated, giving C3H8, which is propane. Here you can see both the molecular and structural formula, again for the first 10 alkanes. Given this condensed structural formula, you can see that as you add carbons in the chain becomes longer and longer and longer and longer. Look at what happens to the boiling points as the chain becomes longer and longer and longer. Those boiling points increase significantly. So hydrocarbons, because they are all carbon-hydrogen bonds, are nonpolar. As the number of electrons in the molecule increases, or in other words, the larger the molecule is, it is very easily polarizable. We remember that that means the London dispersion forces greatly increase. So the greater the London dispersion forces, the larger the boiling point of the alkane. So the higher alkanes have much higher boiling points than the lower alkanes because of their very strong London dispersion forces. Alkanes can form structures in one of 2 ways. And in a straight chain, where all of the carbon atoms are connected in a single row, as you see here, or in branched chains, where alkanes have a row of carbons, but then have branches of additional carbons off of that row. So we see our primary alkane here, but then we see this CH3 branch off of that second carbon. Here's the structural formula for ethane. Ethane contains 2 carbons and 6 hydrogen atoms. We might write a condensed formula to show the connection of those 2 carbons in a straight line, as the first carbon having 3 hydrogens bonded to it, and then the second hydrogen also having 3 hydrogens bonded to it, so CH3, CH3. You can see here the structural and condensed formulas for several pentane alkanes. So the first, just simple straight chain pentane, is 5 carbons all in a single chain. And you can see by this condensed formula that you have carbon after carbon in a straight line. Isopentane, you can see that you only have 1, 2, 4 carbons in the primary chain, and that attached to this carbon, you have a second carbon with 3 hydrogens. So there's that branch right there. And then neopentane, so pentane meaning 5 carbons single bonded, but this structure is highly branched, where we have 1 carbon in the middle surrounded by 4 CH3 groups. So our condensed structural formulas here kind of show us how the carbons are all connected that lead to these different either straight chain or branch chain alkanes.